Imagine if our sun suddenly turned into an invisible ghost, leaving Earth orbiting a freezing, bottomless pit. It wouldn't suck us in like a vacuum cleaner, but if you crossed its invisible border, reality itself would rip apart, stretching your body like a noodle before erasing you from existence. Welcome to the universe's ultimate mystery, black holes. For decades, sci-fi movies made us think they are giant cosmic vacuum cleaners, roaming space, looking for planets to swallow. But the reality is far stranger, and honestly, a lot more terrifying. Think of a trampoline. Place a bowling ball in the middle, it creates a deep dip. Roll a marble nearby, and it rolls toward the bowling ball. That dip is what Albert Einstein called general relativity, the idea that mass bends the very fabric of space and time. Now imagine crushing that bowling ball down until it's smaller than a single grain of sand, but it still weighs exactly the same. The dip it makes becomes infinitely deep. That is a black hole. A massive amount of matter packed into a space so tiny it defies imagination. But here is a mind-bending question. How close can you get to this cosmic trap before you can never, ever go home again? Every black hole has an invisible boundary line. Scientists call this the event horizon. Think of it like a massive waterfall. If you are swimming far upstream, you can paddle away. But once you drift over the edge, the current is too strong. You are going down no matter how hard you swim. For a black hole, that current is gravity. Once anything crosses the event horizon, even light traveling at 670 million miles per hour, it can never escape. But what lies past the edge? If you could survive the fall, you would reach the very center. Scientists call this the singularity. A single point where all that crushed matter lives, where the curvature of space-time becomes literally infinite. A place where our current laws of physics completely break down and stop making sense. You might think all black holes are the same, but astronomers have tracked down 4 distinct types of these monsters. And one of them is so small, it could be hiding right under our noses. NASA and the Hubble Space Telescope have confirmed that black holes come in different sizes, much like animals in a kingdom. First, stellar mass black holes, the corpses of massive stars that died in a blinding flash called a supernova. They pack 5 to 10 times the mass of our sun into a space the size of a small city. Then there are intermediate mass black holes, the elusive middle children of space, caught right between the small ones and the giants. And then the most mysterious of all, miniature black holes. Hypothetical tiny entities that could have formed during the chaotic birth of the early universe, potentially as small as an atom, but weighing as much as a mountain. But those are just the lightweights. What happens when a black hole grows so large it can hold entire galaxies together? In the heart of almost every large galaxy lurks a supermassive black hole. These monsters hold hundreds of thousands to billions of times the mass of our sun. Right in the center of our own Milky Way sits Sagittarius A star, weighing as much as 4 million suns. But compared to its cousins, it is a baby. Look at the black hole in the galaxy M87. It tips the scales at 5.4 billion suns. Its shadow is so gigantic that a single beam of light would take 2.5 days just to cross it. Yet even M87 bows down to the ultimate king, Ton 618. Located 18.2 billion light-years away, this beast is 66 billion times the mass of our sun. So enormous that astronomers had to invent a brand new term for it, an ultramassive black hole. It is 40 times wider than our entire solar system. If our solar system were a coin, Ton 618 would be a football stadium. Now here is a secret most people don't know. These giant cosmic beasts aren't just sitting still in the dark. They are spinning, and doing it at speeds that break reality. But let's get personal. What if you were the astronaut? What actually happens to a human body if you step over the line into a black hole? If you fell into a black hole, you would experience a real scientific phenomenon with a surprisingly funny name: spaghettification. First described by Stephen Hawking in his famous book, A Brief History of Time. It works because of a massive difference in gravity. If you fall in feet first, your feet are closer to the center than your head. Because gravity gets stronger the closer you get, the pull on your feet is vastly more powerful than the pull on your head. The black hole stretches you vertically and squeezes you horizontally, turning you into a long, thin noodle of atoms. In a typical stellar black hole, once you cross the event horizon, you have exactly 12.8 seconds before complete destruction. But here is a counterintuitive twist. Smaller black holes actually cause worse spaghettification than supermassive ones. The giant ones have a more gradual gravity slope at their edge. So if you want to fall into a black hole, pick a giant one, like Ton 618. It is much safer for your first few seconds. But the weirdness doesn't stop with your body. Black holes don't just warp space, they warp time itself. Falling in means entering a time machine. This brings us to time dilation. Einstein proved that gravity slows down time. The stronger the gravity, the slower the clock ticks. Imagine an astronaut flying her scout ship down to the very edge of an event horizon.
Very graceful.
She hangs out there for what her watch says is a quick 6-hour round trip. Meanwhile, her crewmates stay parked far away on the mothership. When she flies back and steps aboard, she would find that she is 36 minutes younger than everyone else. Time literally moved slower for her because she was sitting in the deepest gravitational well in the universe. For over a century, all of this was just math on a chalkboard. No one had ever actually seen a black hole, until a historic morning in 2019 changed humanity's view of the cosmos forever. How do you take a picture of something that swallows light? You don't look for the dark center. You look for its silhouette against the glowing gas surrounding it. On April 10, 2019, a global team operating the Event Horizon Telescope published the first ever direct image of a black hole's shadow in the galaxy Messier 87. It looked like a fiery, blurry orange donut of superheated gas. Imperfect, grainy, and utterly breathtaking. Just a few years later, in 2022, they did it again, capturing the image of our very own Sagittarius A star. These milestones were so groundbreaking that the pioneers of black hole research were awarded the Nobel Prize in Physics. But history didn't stop there. Over the last year, our space telescopes picked up signals that are completely rewriting the textbook on how the universe began. In late 2024 and throughout 2025, astronomy went into overdrive. In September 2025, scientists at Harvard and Smithsonian discovered a supermassive black hole growing at one of the fastest rates ever recorded, sitting 12.8 billion light-years away, meaning we are seeing it just 920 million years after the Big Bang. Then came J2245 plus 3743, the most distant black hole flare ever witnessed. Erupting 10 billion light-years away, this single flare unleashed energy equal to 10 trillion suns. That is 30 times more energetic than any flare previously recorded.
Even the James Webb Space Telescope confirmed an actively growing supermassive black hole inside a galaxy just 570 million years after the universe was born, forcing scientists to ask, how did these monsters get so big, so incredibly fast? And just months ago, in January 2025, an observatory right here on Earth caught a ripple in space that proved a legendary scientist's final theory correct. In January 2025, the LIGO Gravitational Wave Observatory recorded the clearest black hole merger signal ever detected, named GW250114. When two black holes crash together, they shake the universe, sending out ripples called gravitational waves. By analyzing this signal, scientists verified a famous prediction made by Stephen Hawking. When black holes merge, their final combined surface area can never get smaller. It was a triumphant moment for science, proving that even decades later, Hawking's mathematical genius holds true in the harsh reality of deep space. This leaves us with one final haunting mystery. If black holes swallow everything, do they live forever? Or do these cosmic gods eventually die?
Nothing lasts forever, not even black holes. Stephen Hawking discovered that, thanks to the strange rules of quantum field theory, event horizons leak a tiny amount of energy over time. We call this Hawking radiation. As a black hole leaks this radiation, it slowly loses mass. But emphasis on the word slowly. For a stellar black hole with just 10 times the mass of our Sun, it would take 2 times 10 to the power of 67 years to evaporate. An absolute eternity compared to our universe, which is only 13.8 billion years old. For Sagittarius A star, it would take 10 to the power of 87 years. And for Ton 618, more than 10 to the power of 100 years. Long after the stars burn out and galaxies fade away, black holes will be the final residents of our universe. So should we be worried? Let's bust the biggest myth of all. If our Sun suddenly transformed into a black hole with the exact same mass, Earth would not get sucked in. Because its mass stayed the same, its gravitational grip wouldn't change. Our planet would keep orbiting in the exact same path, though we would get incredibly cold and dark very quickly. Black holes are not evil monsters out to destroy the universe. They are a natural, beautiful, and essential part of the cosmic cycle, shaping galaxies, bending time, and pushing the boundaries of human knowledge. Next time you look up at the night sky, remember, out there in the dark, the universe is spinning, warping, and hiding secrets, just waiting to be found.